Good evening, everyone. So, welcome to my YouTube channel, Maths Avtaram. So, today we are going to see second lecture on sequence. So, today we will see what is the uh, upper bound, lower bound, what what type of sequence are called bounded sequences. Okay, let's see. So, bounded below sequences. A sequence AN is said to be bounded below if there exists K1 belongs to R such that K1 is less than AN for all N belongs to N. It means all the terms of sequence are greater than equal to K1. Okay. In this case, K1 is called a lower bound for the sequence AN. Okay. So example I am taking. You take this sequence 1 upon, you take this sequence N. Okay. So An is equal to N. So if I'm taking K1 is equal to 1, then what we have K1, uh, um, so we know that this implies, because N is natural number, so it will be greater than equal to 1. So put K1 is equal to 1, then K1 is less than An for or N belongs to N. So this implies this sequence is bounded below. Okay. And 1 is a lower bound for this sequence. Okay. Now, note that because we can see that if we take K1 is equal to 0, then also 0 is greater than for all N belongs to N. So this implies 0 is also a lower bound for the sequence N. Okay. So what we note that note the mark, there can be there there are more than one lower bound for these sequences. Okay. There can be more than one lower bound for the sequence. Okay. Now another example, I'm taking this one. Example Example 2, I am taking this one. So you take this sequence. Okay. Then you see that then this sequence is always greater than this. Okay. So this implies this sequence 1 plus 1 upon n is bounded below. Okay. And 1 is lower bound for this sequence. Okay. Now I am taking another example. Example 3. To take this sequence minus 1 to the power n. So we know that, so an is minus 1 to the power n, and that is minus 1 if n is odd natural number, 1 if n is even natural number. Okay. So what does it mean? It means minus 1, you take any, n belongs to n. Because if n is a even natural number, it will be 1. 1 is greater than minus 1. If n is odd natural number, it will be minus 1. Then this inequality will be hold. Okay. So this implies minus 1 to the power n is bounded below, and minus 1 is lower bound for this sequence. Minus 1 to the power n. Okay. Now, what is bounded above sequences? Bounded above sequences. A sequence an is said to be bounded above if there exists K2 belongs to R such that an is less than K2 for all n belongs to n. Okay. Okay. A sequence is said to be bounded above if there exists K2 belongs to R such that all the terms of this sequence is less than equal to K2. They do not go above K2. Okay. So let's see. It's in this case, K2 is called upper bound for the sequence an. Okay. So what are the bounded above sequence? Example. Okay, you take this sequence minus n. Okay. Then minus n is always less than 0. for all n belongs to n. So this implies, so we take to put k2 is equal to 0, then an is less than, because an is minus n. An is equal to minus n. So this is for all n belongs to n. So this implies minus n. This is bounded above. Okay. And and 0 is upper bound for this sequence. Okay. Also observe that that minus n is also less than equal to 1. So this implies k2 is equal to 1 is also upper bound for this sequence. Okay. Also upper bound for this sequence. Okay. Now we are taking this example number. So earlier example was number 4. Okay. Example 5. You take this sequence, same sequence we have taken earlier. Now you see that 1 plus 1 upon n is always less than 2. Okay. Reason is that because 1 upon n is less than 1 for all n belongs to n. Okay. So this will imply you add 1 both the sides. So you will get this one. So this implies this sequence is bounded above and 2 is upper bound for the sequence. So in earlier example, we have shown that K2 is also, so there were two upper bounds, 0 and 1. So this implies there can be or more than one upper bounds. Okay. More than one upper bounds. Okay. So we have shown that 2 is upper bound. Here 3 can be also upper bound. Now example number 3. See this example, minus 1 to the power n. You see that minus 1 to the power n is always less than 1, because when n is even, it will give you 1, and when n is odd, it will give minus 1. So this implies minus 1 to the power n sequence is bounded above and 1 is upper bound. 4. Okay. Now we have seen what are the bounded below and bounded above sequence. Now we are defining what is bounded sequence. A sequence AN is said to be bounded if AN is both bounded below and bounded above. Okay. So what is the meaning of this statement? The meaning of this statement is that there exists K1 and K2 belongs to R such that K1 is less than AN and less than K2 and greater than K1 for all n belongs to. Okay. Now example. Now see this example, -1 to the power n. So this is example number 7. Now see that -1. So this is implies AN is equal to -1 to the power n. So this is -1 to the power n always satisfy this. So this implies I'm taking K1 is equal to -1 and K2 is equal to 1. Then K1. So what does it mean? It means this means -1 to the power n is bounded sequence. Now example number 3. Sorry, example number 8. You take this sequence 1 plus 1 to the 1n. Now this sequence is greater than equal to 1 upon, but this is less than 2. So we have lower bound 1 and upper bound. So this sequence is bounded above and bounded below both. So this implies this sequence is bounded sequence. So example 9. This sequence. So we know that we already know that we have already know that this sequence is bounded below. We have shown. But if we take any K2, then and n is increasing. N is what? N is increasing. So we can find a natural number because K2 is fixed. We can find a natural number n naught such that can be go beyond n naught. So this implies this sequence is not bounded above. So this sequence is bounded below, but not bounded above. So this implies this is not bounded because a bounded sequence is, what does it mean? It should be bounded above and bounded below. So if a sequence is neither bounded below or neither bounded below nor, so if a sequence is either not bounded below or not bounded above, then such sequences are not bounded. Okay. So this sequence is bounded below, but it is not bounded above. So it means it cannot be bounded because a bounded sequence is always bounded below as well as bounded above. Okay. Now see another example. Example 10. See this example. So this sequence is bounded above. Bounded above. But this sequence is not bounded below because it is going to minus infinity. If you will fix k1, then there will be natural number whose negative is less than that k1. So it is not bounded. So this implies this is not bounded. Okay. Now we are going to prove a result. Let an be a sequence. Then this sequence is bounded if and only if if there exists k greater than 0 such that k greater than equal to 0 such that absolute value of an is less than k for all n belongs to n. Let's prove it. First, assume that this sequence is bounded. Then there exists k1 and k2 belongs to R such that k1 less than an less than k2. Put k is equal to maximum of absolute value of k1, absolute value of k2. That is non-negative. Okay. Now, then what we have, an is less than k2. So obviously it will be less than absolute value of k2. And this is less than k1. So it will be minus time absolute value of k1. So this implies minus k1 k2. Okay. So this implies an is less than k2 and this is less than minus k1. So this implies it will be maximum k1 k2. Okay. And it will be less than minus time okay maximum of K1, K2. So what is this value actually? This is value minus K. Okay. So we'll put it later. Let's type. This implies minus max K1, K2, max K1, K2. Now what is this? This value is K. So put K here. Kn minus K. Okay. For all n belongs to n. So what is the meaning of this? This means an for all n belongs to n. So this part, so therefore there exists k greater than equal to 0 such that an is less than k for all n belongs to n. Okay. Now conversely assume that conversely assume that an is less than k for all n for some. Conversely assume that there exists k greater than 0 greater than equal to 0 such that such that an less than k for all n belongs to n. So this implies, what is the meaning of this? Minus k. Okay. So we have two parts, minus k for all n belongs to n. You take this much part, okay, and you take this much part. So so this is my k1. So what is the meaning of this? An is bounded below. And what is the meaning of this? An is bounded above. An is bounded above and an is bounded below. What is the meaning of combining these two facts? What is this? This implies an is bounded. Okay. So this is proof. So we will use this result example. Now see this example, minus 1 to the power n. So minus 1 to the power absolute value is actually 1. So this is less than 1. Okay. So an is minus 1 to the power n and its absolute value is 1. So this implies an is less than 1. So put k is equal to 1, then okay. So what does it mean? It means minus 1 to the power n is bounded by above remark. Okay, above remark. Now we are taking another example. Take this. So this sequence is positive. So 1 upon n will be this 1 plus 1 upon n, and that is less than. So what does it mean? It means this sequence is bounded. Bounded by above remark. So today's lecture up to this. In this lecture, we have discussed what is bounded below sequence, bounded above sequence, and finally bounded sequence. And we have given a characterization that a sequence is bounded if and only if there exists k greater than equal to 0, such that absolute value of each term is less than k for all n belongs to n. And we have given some examples. Okay. So we will wind up this lecture here, and we will discuss next topic next lecture. So today's lecture up to this. Thank you very much.